In this video, I will teach you how to tell a compound is aromatic or not. So to do that, what I'm gonna do is I'm just gonna go over three different rules, and then I'll try to apply those and figure out if the compound are aromatic or not. So let's go to the first rule. So the first rule says have a continuous ring of sp2 or sp atom. Before we go into the first rule, you need to know for a compound to be aromatic, the first thing you need to look is if there is a ring or not, or if it's a cyclic compound. So if there is a ring, then you can go to the first rule. So the first rule, continuous ring of sp2 or sp atoms. Let's try to apply the rules on the first compound over here. So from hybridization concept, you know sp2 carbons have double bond, and then sp carbons have a triple bond. So if we apply the rule over here, let's see, on this compound, let's try to find the hybridization of each of these carbons. This carbon is actually sp2, this one is sp2 because it's connected to three different groups. This one is actually sp2. So if you do that, all these carbons over here are sp2, and it has a continuous ring, so that means it has a continuous ring of sp2. So this compound here follows the first rule. So now let's move to the second rule, second compound. So the second compound here, let's try to find the hybridization of each of the carbons here. The same thing here, sp2. So all these carbons have actually sp2. So let's see about this carbon. This carbon is connected to two different carbons and a hydrogen, so that makes it 3 group, which is also sp2. So this compound also follows the first rule. So what about this compound right here? This compound here, actually the third compound, is from the examples earlier, we know these are pretty much the same carbon, so these are sp2 carbons. So the only new carbon here is this one. So what is the hybridization of this carbon? So from here we can see it's connected to 4 different groups. That means this carbon is actually sp3. Sorry, I can write there. So yeah, it's sp3. So that means there is no continuous ring. sp2 here, sp2 here, sp2 here, sp2 here, and the ring breaks because it's sp3. So this compound does not follow the first rule, so it's not an aromatic. Alright, so that's the first rule. Let's move to the second rule. So our second rule says the ring must be flat. Alright, so when you have a ring, then you need to see if there's a continuous ring of sp2, and then then you need to see if the ring is flat. So what that means is the atoms on the ring, actually they must lie on the same plane. So that means if you put them on a table, that means all of them should lie on the table. And this is kind of hard to observe, or hard to imagine. So most of the time what we do is we assume the given compound is actually planar, or or they are flat, unless the question says so. So now let's move to the third rule. So third rule is actually the Huckel's rule, or it's the rule where we count the pi electrons. Alright, so what we do here is we count the pi electrons, and then if we know, and if the pi electrons come to be the actually if they are the multiple of 4n plus 2, then it will be aromatic. If it's the multiple of 4n, it will be anti-aromatic. So 4n plus 2 means if n is 0, then it will be 2, and then if it's n is 1, then it will be 6, and if n is 2, that will be 10. So pretty much it has to be one of these numbers. So let's go ahead and try to apply that on the examples here. So let's look on the first one. So if we have to figure out if this compound is aromatic or not, so the first thing what you need to do is count the pi electrons, right? So there are two ways, or there are two things we need to keep in mind while we count the pi electrons. First, the lone pairs, and then second is the pi bond. Alright, so and it's very important to understand that if an atom has more than one lone pairs, you just count it as one lone pair. That means, if an, like over here we'll go over, if oxygen has, here it has more than one lone pair, it has two lone pair, but we just count one. So same thing with the pi bond. If a compound has, or if an atom has more than one pi bond, we just count one pi bond. So here let's go ahead and count the pi electrons. There's one pi bond, that means two pi electrons. There's another pi bond, that means another two electrons. Since even though there are four lone pairs, we just count one lone pair, that means two more. So that means two pi electrons from here, two from here, two from here. That means it makes it 6. If it's 6, then it's aromatic. Alright, now let's go ahead and look on the compound right here, the second compound. Okay, if you look on the second compound here, let's go ahead and count the pi bond first. One pi bond means two pi electrons, another pi bond, another two, there's one more pi bond, so there is 6 pi electrons from the pi bond, and there is another 2 electrons from the lone pair. So one, that's 2, 4, 6, 8. So that means it has 8 pi electrons. That means it's multiple of 4n, which means it's anti-aromatic. So let's look on our last example here. Alright, so we'll do the same thing here to count the pi electrons. So let's go ahead and count the pi bond first. So there is one here, that means two electrons, pi electrons. There's two, there is three, and there is four. So that means 2, 4, 6, 8. There is 8 pi electrons from the pi bond here. So do you have any lone pairs? Of course we have a lone pair at sulfur. So even though it has more than one lone pair, we just count 2 electrons from one atom here, right? So that means 2, 4, 6, 8, 10. That means it has 10 electrons, or 10 pi electrons. So 10 is actually a multiple of 4n plus 2. So this is aromatic, this is aromatic, and this one is not.